we are the Bricksmart team. My name is Kabir.
I'm Nick.
I'm Devin. I'm Chloe.
Leave it. Just leave it.
Just leave it, Devin. Let him do it.
As you can see in this diagram of Newton's first law,
How does that even show Newton's first law?
well, if you look at the formula, it shows how wah 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 wah.
I'm so bored.
Class dismissed.
Fine. Hey teacher, over here.
What?
Go ahead and go.
Where am I? And who are you?
I am Isaac Newton, and you are in Newtonlandia, and you need to change your ways of boringness. I have found the way to teach all types of students my 3 laws through hands-on activities. Because students struggle to connect with what's being taught, they fall behind. And it's even more of a struggle when students are coping with learning challenges. Luckily, there are simple and proven tools to help keep students connected with what's being taught. Hands-on activities create an exciting environment for learning and also connects concepts to the real world, all the while teaching desired educational lessons.
Oh, really? I bet they don't teach a single law as good as I do.
We shall see about that.
We will demonstrate 3 hands-on models that we have built. Number 1, law of value.
An object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. As you can see in my model, this object, if I push it, it doesn't go that far because of friction. And if I put it on some of these magnets and I push it, it'll go much further because there's less friction, but it doesn't take all the friction away.
Law 2, Nick.
So, in Newton's second law, it is force equals mass times acceleration. And that means, with more force, a mass of the same size, of the same mass, will have a greater acceleration. So, in order to use this demonstration, you must pull this rubber band back to different lengths, which will there increase the force. So, first we will turn on the program. Next, you pull back the rubber band. I will press this button and it clamps down on the rubber band. Then I will put the cork in place. And I have a program that will measure the time it takes from when the motor releases the rubber band to when the cork hits the plate and triggers a touch sensor. And then it displays the time it takes. So, 3, 2, 1. So, if I did that one more time, the speed would be much greater. And
Now, law number 3.
Law 3 states that every action has an equal and opposite reaction. This model, a balloon car, displays that law because the action that's happening is the air coming out from the balloon out of the straw, and the reaction is the air that's already present in this room. The action comes out of the straw, and then the reaction is equal and opposite force, which propels the car forward. Wow, that was amazing.
thank you, Newton, for showing me these excellent ways to teach.
You are
Even my
welcome.
most challenged students will be thrilled to learn.
You are welcome, but you must return to your class on Earth.
Thanks again.
Finally, you will teach my laws correctly. Now, who else do we have to enlighten? You can be enlightened at our website, www.newtonlandia.weebly.com.
Alright, class. So, let's look at this.
Or just look at the one on the table. Rather than taking time to pick it up, just go with that.
Let's look at this model that demonstrates Newton's second law.
Wow.
No.
I finally understand.
Good.
And you know, it might be. Oh.
Okay, then he says.
Thank you. That was our skit. Do you have any questions?